for the mainline design in TURBOdesign Pre, we start by selecting the machine type, which is centrifugal pump in this case. Then the next section is the spec tab, where we need to input the design point specifications, which is the stage head, the rotational speed and the flow rate, which are generally part of the customer specs. And the working fluid in this case is liquid hydrogen. And one thing you should be aware of is obviously for liquid hydrogen at these conditions, vapor pressure is quite high. So cavitation for this pump is a real challenge that we need to address very carefully in the design. And so we need to use an inducer given the low suction pressure that we have. And in fact, to add an inducer in TD Pre is very easy. And for this, we just have to select the inducer component here. And of course, we have selected the impeller and volute components for a full stage design. And then we have this specific speed diagram here, which immediately shows that this design sits near the peak of the centrifugal region. And so the given specs can lead to a high performance centrifugal pump. Now the next section is stage composition, where we specify some more details about the different components. So starting with the inducer, we specify what fraction of the stage head we want from the inducer, and then for the calculation method we need to specify any two of these different parameters, and then the Meanline code optimizes the meridional shape to maximize the suction specific speed for the given flow coefficient. And we can also impose some optional parameters here. For example, if we want the inducer hub and tip to be flush with the impeller inlet for a compact design. And then next, for the impeller, we need to specify the inlet hub diameter, which generally comes from shaft strength considerations. It's also possible to specify leakage at the front or back of the impeller, the outlet velocity calculation method, and the number of blades. And then for the volute, we can go with the elliptic asymmetric section, which is commonly seen in turbopumps, where space is at a premium, the fast linear calculation method, and a sizing parameter of 1 for perfect conservation of angular momentum, and then some other dimensions for the discharge tube. Now we don't really need to change the convergence parameters, and then we can run the calculation, and in just a couple of seconds we have the flow path along with some basic dimensions and estimates of stage efficiency, and the RVT star, which is like the work coefficient for the different components along the stage. And then as we scroll down, we have some more details on individual components, such as the pressures and velocity triangles as well. And then finally, with a single click of this button here, we can save all the files which will later be used for the 3D inverse design of the inducer and the impeller blades in Turbodesign 1. And we also have these performance curves available, such as the stage head against the flow rate. And so this is the design point, and you also get some idea of the off-design performance at other flow rates and at other rotational speeds. And then we have the efficiency map, where we can see that the duty point has been met at a sufficiently high efficiency level, and finally some power curves too. And with that information, we can then proceed to the 3D design of the different turbopump configurations in Turbodesign 1.